In this video, we're going to be tackling the LeetCode question, remove element. And this is another one of those questions that would be easy if it weren't for that pesky in place constraint. Yes, we have to modify this array in place, and that means a couple things. Number one, we can't use the word new. We can't create a new array and put the elements that we want inside of it. That leaves out a very easy path to solve this question. Also, we can't use LINQ or streams. LINQ and streams are frameworks that are built upon returning new arrays. And also, we have to worry about the fact that arrays are very similar to diamonds. You can shrink a diamond. It's definitely possible to shrink a diamond. You can split it in half, but splitting a diamond in half costs a lot of money. It's not going to be fun. And it's the same thing with arrays. To shrink an array takes an act of God. But if we just want to leave the array as it is, and let's just take things step by step. Let's just slow down and let's just talk about this algorithm for a second. So here's how this is going to work. We're going to have two things. We're going to have a single number and we're going to have an array. And our job is to remove this number from this array. This number is 3. We want to remove the 3s from this array. We do not like 3s. No 3s allowed. How exactly do we do that? Well, what we're going to do is we're going to move the numbers that we do want. We want 2s and we don't want 3s. And we're going to move the 3s to the back. And congratulations, you have solved the algorithm. You may be thinking to yourself, well, there's 3s left over in the array. These numbers could be anything. This could be null, this could be 2. LeetCode is just going to give you a solid and they're going to say, hey, we know that shrinking an array is very hard and we're not going to expect you to shrink the array to fit to the 2s. So what we're going to do is we're just going to give you a gimme and we're just going to allow you to put anything for those last numbers. And that's why it's denoted by an underscore. Now, this is a pretty cool algorithm, but step by step, how does this work? So we are going to move step by step through each element with a for loop, and we're going to check for elements that we do want. We don't want 3s. So once we come to a 3, we're just going to skip it. We're not going to do anything with it. But once we get to a number that we do want, we're going to move that number to the front. So we're going to go ahead, we're going to swap the 2 with the 3. And remember, we need to keep track of all of the elements that we've moved to the front. So what we're going to do is we're going to go ahead and increment it by 1. And this process is going to repeat. We're going to move to the second element. This is indeed a number that we do want. So we're going to go ahead, move it to the front. We're going to swap out the 3. And we're going to go ahead, we're going to increment our valid index. And lastly, none of the other numbers matter because 3s are numbers that we don't want. These are the elements that we're trying to remove, and LeetCode doesn't care about their value anyway. And that is the end of the algorithm. So let's go ahead, let's hop into IntelliJ and let's code it. So we're inside of IntelliJ, and the first thing that I'm going to do is create a brand new Java class, and I'm going to call this solution. Within the solution class, we're going to create a method, and this method is going to return an int. It's going to return a number. And this number represents the number of elements at the front of the array, the number of elements that we do want. Then what we're going to do is we're going to call this function, this method, remove element. And it's going to take in an array, and it's going to take in an integer. And that's the number that we want to remove. So we need to keep track of the front of the array. And I'm going to call this valid index. But you could also call this front. You could call this front number. Basically anything that's going to keep track of and remind you that this is the number at the front and this is the number that we need to increment as we find numbers that we want. So we're going to create just your standard run-of-the-mill for loop. We're going from the front to the back. What we're going to do is we're going to check through each number that we iterate. And if it's a number that we want, a number that we don't want to remove, we're going to move it to the front. Hence the negation. This is a number that we want to move to the front. To move the element to the front, what we're going to have to do is we're going to have to do what's called a swap. And we're going to store one of the elements that we plan on swapping in a temporary variable. And the reason that we have to store it in a temporary variable is simple. Let's go back to our example. Let's say we want to move the 2 to the front because the 2 is the number that we do want. Well, we're going to have to swap it. But when we swap the 2 for the 3, watch what happens. There's no 3 to swap from. We overwrite the 3 that we need to move to the right. So what we do is we store it in a temporary value so that we can access it when we need to do the second move. So we've got our temporary variable figured out. Now we can do the actual swap. And the swap looks just like this. This is the temporary variable, and we're going to switch the number that we are at in the iteration, and we're going to switch it for the valid index. Then what we're going to do, we're going to take the index that we're at, and then we're going to switch it with the temporary variable. And then at the very end, we're going to go ahead, we're going to move our front. We're going to move our valid index up. Now, we still have to return a number. We have to return an integer. And what we're going to return is the valid index. And again, just to recap, the valid index is the number of numbers that we do want, the number of numbers at the beginning of the array. And the valid index is the length of this. And we created it as we were indexing. And the valid index, remember, does not include the numbers that don't matter. So let's go ahead, let's copy all of this, and let's toss this into LeetCode and see if we get a pass. So I'm going to go ahead and get a full screen here, pull up LeetCode, going to paste this into the editor, little Control-C, Control-V, and we're going to run those tests. Yes, we passed. Let's go ahead, hit the submit button. Let's check our time complexity and make sure we're modifying in place. So time complexity is n linear. And our memory is constant. We are in place, guys. Anyways, hope that you enjoyed this. If you did, smash that like button, smash that subscribe button. As always, thank you for watching.